Welcome to Designing with Uncertainty. In modern human-computer interaction, especially with AI-driven systems, uncertainty is not a flaw, but a fundamental condition. Systems operate on predictions, incomplete data, and evolve constantly. Many systems inherently don't know, can't guarantee accuracy, and change over time. This video will explore how to design for this reality. Uncertainty in human-computer interaction manifests in two primary forms that designers must understand and address. These are epistemic uncertainty, which arises from limitations in knowledge, and aleatory uncertainty, which represents inherent randomness. Epistemic uncertainty originates from gaps in our understanding or available information. This type is reducible because it can be addressed by gathering more data, improving models, or enhancing knowledge. In AI systems, this often appears as incomplete training datasets that fail to capture the full range of real-world scenarios, leading to variable model performance. In contrast, aleatory uncertainty represents fundamental randomness that cannot be reduced through additional knowledge. It stems from the inherent variability in natural processes and human behavior. For instance, user interactions with interfaces are inherently unpredictable, making it impossible to guarantee exact outcomes regardless of data quality. While epistemic uncertainty can be mitigated through better data collection and model refinement, aleatory uncertainty requires design approaches that accommodate variability. Large language models exemplify this duality, suffering from epistemic issues like biased training data, while also dealing with aleatory factors such as diverse user inputs. The trade-off between model accuracy and explainability further complicates design decisions. Effective design requires probabilistic approaches that acknowledge and communicate uncertainty. By clearly indicating confidence levels and providing mechanisms to handle variability, interfaces can build user trust while managing the inherent unpredictability of AI systems. Training bias, as shown in this diagram, represents a critical epistemic challenge that probabilistic design must address. Navigation apps like Google Maps demonstrate uncertainty in action by predicting estimated times of arrival, but they communicate this uncertainty effectively using visual cues called traffic cones. These cones represent confidence intervals around the predicted route, showing users not just one exact time but a range of possible arrival times. This approach builds trust because it acknowledges that real-world conditions like traffic or road closures can vary, allowing users to make informed decisions rather than expecting perfect accuracy. Health applications like Apple Health illustrate uncertainty through AI-driven predictions of health risks, such as potential disease likelihood based on user data. However, these apps responsibly include disclaimers that acknowledge the limitations of the data and algorithms, stating things like based on available information or not a substitute for medical advice. This detailed transparency is crucial because it prevents users from over-relying on potentially inaccurate predictions, encourages consultation with healthcare professionals, and maintains ethical standards in health technology. Even advanced artificial intelligence systems like ChatGPT-5 handle uncertainty by attaching confidence scores to their responses. For example, a response might come with a percentage indicating how certain the model is about its answer, such as 85% confidence. This quantification allows users to evaluate the reliability of the information provided, helping them decide whether to accept the response as definitive or cross-reference it with other sources. It promotes critical thinking and responsible use of AI technology. Content moderation systems on platforms like YouTube use AI to flag potentially problematic content, but they incorporate uncertainty by assigning probability levels, such as 60% likely to be spam. This approach prevents automatic removal of borderline content, instead escalating it for human review. It strikes a balance between maintaining platform safety and avoiding over-moderation that could unfairly suppress legitimate content, demonstrating how uncertainty-aware design supports fair and effective digital governance. A fundamental strategy in designing with uncertainty is transparency through confidence levels. This approach involves clearly communicating to users how certain or uncertain the system's outputs are, helping them make informed decisions rather than relying on potentially flawed assumptions. Displaying uncertainty visually is essential for effective communication. Confidence bars and error margins provide immediate visual cues about the reliability of information. For example, in data visualization, error bars on bar charts show the range of possible values, helping users understand the variability and potential risks in the data. Error margins are a specific type of confidence communication that shows the potential deviation from an estimate. In statistical terms, this represents the margin of error around a point estimate, indicating the range within which the true value is likely to fall. This helps users contextualize information and make more realistic expectations. In health applications, communicating confidence levels has shown significant benefits. For instance, when apps display uncertainty like 80% confidence in hydration needs, users are better informed about the reliability of recommendations. Studies have found that this transparency improves user adherence by 25%, as people feel more empowered to make appropriate decisions, rather than blindly following potentially inaccurate suggestions. The key challenge is balancing transparency with usability. While confidence levels provide valuable information, displaying too much uncertainty can overwhelm users and lead to decision paralysis. Designers must carefully consider how much information to present, using progressive disclosure techniques where basic confidence indicators are shown first, with more detailed uncertainty information available on demand. Ultimately, effective communication of confidence levels builds user trust and enhances the overall experience. By thoughtfully implementing these strategies, designers can create systems that acknowledge uncertainty while empowering users to navigate it successfully. Another key approach is to offer alternatives when uncertainty is high. For instance, instead of solely relying on AI-driven recommendations, provide manual overrides or multiple options. This allows users to choose different paths when the system expresses uncertainty about the best choice. Enabling user control is vital for building trust in uncertain systems. By allowing users to probe uncertainties, adjust parameters, and make informed decisions, designers empower users rather than leaving them at the mercy of automated processes. This collaborative approach reduces anxiety and increases engagement. A concrete example of this strategy in action is content moderation systems like YouTube's AI, which now include appeal processes. When users can challenge automated decisions, it significantly boosts trust. Research shows appeal options increase user trust by 35%. This demonstrates how giving users control over uncertain outcomes transforms potential frustration into confidence. Graceful degradation is a key strategy for designing systems that handle uncertainty by failing softly rather than crashing completely. Instead of abrupt system shutdowns, these systems maintain partial functionality and guide users through uncertain situations. A prime example is Tesla's autopilot system. When the AI detects low confidence in environmental understanding, such as poor lane detection, it doesn't continue autonomously. Instead, it displays clear prompts requiring manual driver intervention, preventing potential accidents in most edge cases. This approach minimizes disruption and preserves user trust by acknowledging limitations transparently. Even when encountering unexpected scenarios, the system continues operating at a reduced level, offering alternatives rather than complete failure. The principle extends to distributed systems, where components can fail gracefully without causing total system collapse. Core services remain available, allowing users to continue essential tasks while degraded features are temporarily unavailable. A common pitfall in designing interactive systems is hiding uncertainty from users. HCI expert Yvonne Rogers argues that this erodes trust more than any error, because users expect transparency in systems they rely on daily. Conversely, over-asserting certainty in systems that are biased or unreliable can have serious consequences. When designers present uncertain information as definitive, it can spread misinformation and cause users to make poor decisions based on false confidence. A prime example is Waze's early versions, which over-asserted certainty in their traffic predictions. Users relied on these confident estimates, but when unexpected traffic conditions arose, the lack of uncertainty indicators led to navigation errors and frustration. This case highlights how overconfidence in AI systems can undermine user safety and trust. Good design doesn't eliminate uncertainty, it acknowledges and helps people understand and work with it. HCI pioneer Ben Schneiderman argues that designing for uncertainty is designing for humanity. By embracing uncertainty, communicating it effectively, and providing user control, we can build more resilient, trustworthy, and ultimately more human centered interactive systems.